semiconductor junction diode as a rectifier. Semiconductor junction diode as a rectifier. The process of conversion of AC into DC is called rectification. The process of conversion of AC into DC is called rectification, and the instrument used for the purpose is called rectifier. R-E-C-T-I-F-I-E-R, rectifier. So what is rectification? The process of conversion of AC into DC is called rectification, and the instrument used for this is called rectifier. Since junction diode conduct current only when it is forward bias, hence it can be used as a rectifier. So this is the circuit. So this is a step down transformer. AC voltage is applied here. This is 220 volt. Say this step down transformer converted 220 AC volt to 20 volt AC here. Okay. Then this is a PN junction diode. This is a PN junction diode. This is called P and this is N. This is a PN junction diode. And this is the load resistance. The output is taken across it. Output is taken across it. So this is the input AC. Say this is the positive half of input AC. This is the negative half of input AC. Say during the positive half of input AC, the A terminals becomes positive, then B will become negative. So if A positive, B negative, this diode is key. Diode is reverse bias. Sorry, diode is forward bias. When A is positive, B is negative, P will get positive voltage, B will get negative. As a result, this diode is forward bias. Therefore, current flows through the circuit. As the input voltage increases, reverse biasing voltage increases, so current through the diode increases. Therefore, voltage drop across the load resistance. Voltage drop across the load resistance increases. So, therefore, output voltage increases. Now, here input voltage decreases. So, therefore, output voltage decreases. In the next half, what happens? A becomes negative, B becomes positive. Because it is alternating current. A becomes negative, B positive, which makes the diode reverse biased. So under reverse bias condition, no current flows to the junction diode. Therefore, voltage drop across the output or the load, voltage drop across the output is 0. Therefore, output voltage is 0. Again in the next half, A becomes positive, B negative, which makes the diode forward bias, and hence current flows to the diode and we get the output voltage. So this is called the rectification process. It is because whenever current passes to the load resistance, it always flows in this direction. In this half, in the negative half of input AC, no current flows through it. Okay? That means whenever current flows to the load resistance, it always flows in this direction. This unidirectional property is called current. Current is called rectification process. Then you may say one thing. So here the output is pulsating one. But with the help of a filter circuit, we may reduce this pulsation. Pulsating মানে বুঝি পাইছো না, প্রথমতে বাঢ়িছে কমিছে আকৌ নাই আকৌ বাঢ়িছে কমিছে, কিন্তু এটা ফিল্টার সার্কিট ইউজ কৰি আমি এই রেক্টিফিকেশনটো কি কৰিব পাৰিম, কমাব পাৰিম। মানে নট রেক্টিফিকেশন, যে পালসেটিংটো আমি কি কৰোঁ, কমাব পাৰিম। Here the necessary circuit diagram is as shown in the figure along with the input and output waveform. Draw the junction diode as a half wave rectifier. You have to draw this circuit diagram and you have to also show this particular case. So it is very nicely explained here. I will give you the notes to you. Now junction diode as a full wave rectifier. Junction diode is a full wave rectifier. This is a circuit diagram. This time our transformer is a center tapped step down transformer. Tapped T-A-P-P-E-D. That means its output has 3 wires. Its output has 3 wires. This is the middle wire. Generally number of turns in this part must be equal to number of turns in this part. This is called center tapped step down transformer. So this is the necessary circuit diagram. With the terminal A, this diode is connected. With terminal B, diode D2 is connected. This is the load resistance. This is the load resistance. Okay. Say during the positive half of the cycle, A becomes positive, B negative. And during the negative half, B positive, A negative. Therefore, waveform structure would be like this. When the end A of the transformer, secondary of the transformer positive, end B is negative. When end A is negative, end B is positive. Okay? So this is the input waveform at end A. This is the input waveform at end B of the secondary of the step down transformer. When the A terminal is positive, B negative, this makes diode D2 reverse biased and diode D1 forward biased. Forward bias means key. Positive end of the battery is connected to P side and negative end to the N side. A reverse bias means negative terminal of the battery to the P side and positive terminal to the N side. When end A positive, end B will be negative. So therefore, this is positive, P positive, A diode to forward bias, B to negative, A diode to reverse bias. As a result, current flows through the diode D1. It is represented by dotted lines. Have you seen it? It is represented by dotted lines. It will flow like this. That means current flows along the direction A D1 X Y. Okay, CA. So therefore, we get the output. Voltage. In the next half, B positive. B positive, A negative. This makes diode D1 reverse biased and diode D2 forward biased. Therefore, current now flows in the direction represented by solid arrow. Have you seen it? That means current flows in the direction B, D2, X, Y, C, B. That means that in both the half of input AC, current flows through the load resistance in the direction from X to Y. So when D1 is forward biased, D2 is reverse biased. In that condition, current flows from X to Y to the load resistance as represented by dotted arrows. And when D2 is forward biased, D1 is reverse biased, then also current flows to the load resistance in the direction as shown by the solid arrow. Since in both the half of input AC, current flows through the load resistance, we get the output voltage, and therefore it is called full wave rectification. That means whenever current flows to the load resistance, it always flows in the same direction for both the half of input AC. That means whenever current flows to the circuit, current flows in the same direction from X to Y for both half of input AC. Therefore, it is called full wave rectifier. When A terminal is positive, B is negative, diode D1 is forward biased. When A negative, B positive, diode D2 is forward biased. When A positive, B negative. Okay? So explanation is here. Thus, the diode conduct current through the load resistance for both half of input AC. So this is called full wave rectifier. Okay? You see the circuit diagram? Now, filter circuit, we have seen that this is a full wave rectifier, we have seen that. So this is the input AC, and this is the input AC, and this is the output, rectified output across the load. This is the rectified output across the load. Have you seen it? This is the input AC, and this is the rectified output across the load, and this is the filtered output. That means in this case, the resistance current is unidirectional. Current is unidirectional to the load resistance, but value is changing. What is DC current? DC current means constant current in a fixed direction. Here, direction is fixed. But magnitude of current and voltage changes. So therefore, we have to filter it. And this is called a filtered output. So what is filter circuit? A filter circuit is a device which removes AC components of the rectified output but allow the DC component to reach the load. A filter circuit is a circuit or it is a device which removes the AC component of rectifier output, but allow the DC component. The most commonly used filter circuit are the capacitor filter. We know that through the capacitor, AC current can pass, but capacitor block the DC voltage. It is already discussed during the study of alternating current that capacitor block DC but allow AC. So as soon as this rectified output reaches the point X, the AC component passes to the capacitor and DC component has to flow through the load resistance. যেতিয়া এই পালসেশনটো ইয়াত আহিব, যে তোমাৰ কি হ'ব, এসি কম্পোনেন্টটো ইয়াৰ মাজেৰে গুচি যাব আৰু ডিসি খিনি ইয়াৰ মাজেৰে যাব. As a result, we get a constant voltage across the load resistance. মই বেছি ভালকৈ তোমাক কৈ আছো, from here to here, as the voltage increases, this capacitor gets charged. Now, when this part is reached, have you seen it? When this part is reached, what happens? Voltage at X decreases. A এইটো পাৰ্ট আহি যোৱাৰ লগে লগে এক্সত ভল্টেজ ডিক্ৰিজ হ'ব, তেতিয়া কেপাচিটৰটো ডিসচাৰ্জ হ'ব। কেপাচিটৰটো ডিসচাৰ্জ হয়, চোৱা কেপাচিটৰটো ডিসচাৰ্জ হ'ব। ইন হুইচ ডিৰেকশ্যন? ইন দিছ ডাইৰেকশ্যন। As a result, current through the load resistance remains constant. Current through the load resistance remains constant. Therefore, we are getting a constant DC voltage. Again, in this part, again capacitor gets charged. Or in this part, the capacitor gets discharged. So, we get a constant DC voltage across the load resistance. Okay? As the rectified input voltage increases, at the point X, as the rectified input voltage increases at the point X, the capacitor gets charged. At the end of quarter cycle means here. From here to here half cycle, this is at the end of quarter cycle. At the end of quarter cycle, as the input voltage at X decreases, capacitor get discharged. Capacitor get discharged to the load resistance, keeping the voltage across RL constant. In the first quarter of the next half cycle, again the capacitor gets charged and the process is repeated. Thus, we get a constant DC voltage across the load resistance. So, this is called a filter circuit. What is filter circuit? A filter circuit is a device which removes the AC component of rectified output and allow only the DC component to pass through